Right, so I've got two balls here, and they're identical in how they look. They're the same mass, but they bounce differently. So the one that doesn't have the orange tape on it, that's the sad ball. It hits and it doesn't bounce at all. The one that has the orange tape on it, it's a bouncy ball, and it bounces nicely. So what I'm going to do is I'm going to bounce both of these balls against this mailing tube. And if it works the way I hope it does, hope it will, the one that doesn't bounce will cause it to teeter, but not topple. So it teeters, but it doesn't topple. When I do it with the one that bounces, it does more than teeter, it topples. So they're the same mass ball, but it turns out that because of the bounce, it gives it a larger force. Why? That's a bigger change in momentum than this one. So I've got some numbers up here. And the numbers are kind of fake, but the idea is correct. The sad ball comes down, and right before it hits the mailing tube, I'm saying it's got a momentum of 1. Of course, after it hits the mailing tube, it stops. So its momentum is 0. And then, if you look at its change in momentum, it would be 0 minus 1 or negative 1. And I'm saying that the time for the interaction is a 20th of a second. So if you put it into the impulse equation, that change in momentum over that 20th of a second gives you minus 20 newtons. What about the other one? The difference with the happy ball is it comes down, it has the same momentum when right before it hits, but it bounces a little bit. So now it's got some negative momentum in the opposite direction. Not a whole lot, but when you look at the change in momentum, this negative 0.2 minus the 1, you get a little bit larger change in momentum. And assuming the times are the same, when you divide that larger change in momentum by the same time, you get a little bit bigger force. And so for the Pelton wheel, it means if that water reflects off of the blade rather than just hitting it and rolling off, it's going to be a larger force. It's going to make the wheel turn at a faster rate. So here's a question that I've used on tests before. If you had a choice between getting hit by a clay ball, or a hunk of clay, or a bouncy ball that had exactly the same mass, which would you choose? Hunk of clay is the right answer, because you'd have less of a change in momentum, and therefore your body would be giving it less of a force, and therefore it wouldn't hurt as much, or you wouldn't get bruised as much.
What do you mean? What do you mean?